Okay, good afternoon, everyone. Welcome to today's lecture. I think it's pretty obvious. I had quite a tough week, so I'm going to ask that you bear with me. I haven't spent the amount of time last week on this that I would have liked to because of circumstances. I'm not going to drop you. We still have a lot of time together, and we're still going to add great value. All right, guys, I want to share something about tests and assessments, though I am going to talk about that at the end of the lecture because not everyone has joined yet. So let's perhaps start with the lecture before we get there. I'm not going to spend a lot of time on this today. We're going to work through these slides and we're going to talk about life cycle. All right, so the topic that we're on at the moment is bringing systems into being, right? So how do we create systems? So remember, the first two chapters is all about introduction and theory, and then the later on chapters we'll start applying that theory. All right, so we started talking about life cycle considerations in systems design, right? Today we're going to get some more insight into what is it that we consider when we do design a system. Is it just the product? Or what are we talking about when we design systems? Remember, we said systems engineering started with in the aeronautical industry, right? So why did it start there? Remember, the aeronautical industry works to very fine safety factors. To be competitive, everything has to work really, really well, and everything has to be very, very efficient. And a way to get there was for them to start developing a concept that we call systems engineering today. And after they applied it in the industry and they realized that this works really well, they started applying it to nearly all manufacturing industries. And that's why we're considering this course, right? So that means that in systems engineering, we have to look at the entire system. It sounds pretty stupid, right? It sounds pretty straightforward. But when considering systems engineering, we have to consider the entire system. And that's not just the product, right? We're not just talking about the system. We're talking about the system within which the product is being produced. And that's why I said today we're going to start looking at what do we consider when we do systems engineering, when we design a system. So we were talking last week, or the week before that, apologies, about life cycle, right? Where the life cycle starts, where it ends, and what must be considered. We had a look at the cars. Remember, I showed you the Nissan X-Trail and the VW Tiguan, and I showed you the VW Polo versus the Nissan Micra. And we had a look at some of those after-sales stuff and some of those additional stuff that's included into the system, right? So when we talk about Industry 4.0, we talk about what the environment is looking like. Let's say, competitive environment in which organizations or companies function. What does it look like? Today, we sit at a place where we can order something from the US and it can be delivered to our doorsteps within a couple of days, right? So what does that say? It says that we sit in an international market, and in an international market, in a capitalist model, what is the effect of that? What is the effect of that? So the competition rises. What is the effect of competition? Guys, when we're online, please keep ourselves muted unless you want to ask a question, please. Otherwise, there's quite a lot of reverb that happens. So please just, everyone, check if you are muted. Just make sure that you're muted. Thank you so much. All right. So no, there's still someone that's unmuted. Maybe I should go and check. All right. Guys, so what's the effect of competition? So it's good. Competition is good. Why? It's good for the customer because it reduces cost, improves quality, all of that stuff. Not necessarily always, but most times. But as a company, as a systems engineer, what's the effect of competition on us? Well, available resources start to dwindle. I remember when I was back at Varsity, when I was at Varsity, we did a sideline project where we designed a component. I can't tell you what, but we designed a component out of carbon fiber. right, for one of our projects, sideline projects. And I went up and down in South Africa looking for carbon fiber, couldn't find any. All right, so there was, look, it was a long time ago, so carbon fiber wasn't as readily available then as it is now, but we couldn't find carbon fiber. And asking around, the suppliers told us, no, that's the A380, the Airbus A380 aircraft that they were busy producing. Some of the components on them are produced out of carbon fiber. Because they're producing at such a large scale, they're basically buying up the entire world's carbon fiber supply, or at least the free supply, the supply that's available for other consumers as well. So we couldn't get carbon fiber. So that gives you an idea of how available resources dwindle, right? Precious metals, all that type of stuff starts to dwindle, which makes the prices skyrocket. A good example of that, obviously there's other circumstances, but a good example of that is oil prices, right? Because oil price, or oil at least, is a limited commodity. So what is that? What happens? Those resources dwindle. Many organizations downsize. Why? Because you have to stay competitive. You have to produce at a certain cost. And how do you do that? By reducing overheads. So then you can make your company more lean. So how do you do that in an organization? In order to reduce overheads, you downsize. So you improve your operations, make everything more effective, and you seek international partners that are very good at what they do for very cheap. A good example of that is the other day, a friend and I were speaking about software that he wanted to develop, but it included some blockchain coding, some blockchain design, this product that he wanted to produce. And he said that he couldn't find someone in South Africa that is specialized enough, and secondly, that works at a price that is actually affordable in South Africa. So what he did was he went overseas, advertised on some other bulletin board, and got programmers out of India that work at a fraction of the cost that South Africans work at, that are experts in the field of blockchain, and coded it for him in a week's time. And he got the code and he went on with his project. So seeking international partners, looking to improve their operations, downsizing, and then also the reduction of the number of suppliers and subcontractors able to respond. Right, so I was working at Water Affairs. There tenderpreneurs and all of that stuff. We launched a couple of tenders. These were big tenders, but very often our tenders were failures because we only had 1 or 2 respondents, right? Because to be able to filter such a large environment and so many competitors, we had quite a number of requirements. And because the contractors that were able to fit those requirements were busy on other projects, we couldn't have enough respondents. We very seldomly had 3 or 4 respondents. We had 1 or 2, and then we had to redo the tender. It was because people of that caliber are already used. So we were struggling to get suppliers. Why? Because in this competitive environment, they were already busy on other jobs that paid them better. All right. So in that regard, international, especially international competition, in an environment where if you're a subcontractor in South Africa, you can rather go and look for European money or Middle East money instead of looking for South African money, which pays a lot more. All right, so in that way, competition affects us all, and that has become more and more and more important in the more internationalized environment. So to ensure that we are economically competitive regarding our end item, regarding our product, our engineering must become more closely associated with the economics and economic feasibility. So us as engineers, we can't just produce for the technical regard. We have to consider cost all the time. In the materials that we use, in the methods that we use, in the facilities that we need to produce this product, we can't just design a product anymore. We have to be able to consider all these other factors, including right through the entire life cycle, right? So starting right from conceptualization to the end. As engineers, we can't just produce a product anymore. It has become so competitive that we have to consider other things influencing the product, influencing the entire system cost, right? So this can be accomplished through the life cycle approach, especially through systems engineering, right? So this we spoke about the other day. What is this product life cycle? The product life cycle starts by the identification of the needs. And then sometimes your customer doesn't even know what the needs are. Remember what we spoke about, that fashion design where the guys had to predict what next year's fashion will be like. And I don't know if you know, but the fashion works in a 52 cycle per annum. So every single week, these days, they consider a new season. All right, so they have to predict for every single week next year the needs of the customers. And if you don't believe me, you can go to, I think, Edgar's or Woolworths, and you can go and check on the shelf, on the tag, on the label, there's a little number at the bottom. And that number signifies the week that this thing will be sold. Why? Because they want to keep you in the shops every single week. So it starts with the identification of the need, and then conceptual and preliminary design, then detailed design and development. That detailed design and development obviously doesn't end with the product. It also includes the manufacturing system, right? The plant that you need to produce that product and all other infrastructure. Then production and or construction. And then a very important phase, which is often overlooked, and this is what we spoke about last week about that after-sales service, is product utilization, phase out and disposal. We went through this during our last lecture. So system lifecycle engineering goes beyond just the product lifecycle. And so we just spoke about that. When you look at system design, we can't consider the product anymore. There's other things that we have to consider. We just realized why, because of international competition, to be able to stay competitive in this environment, we can't just consider the product anymore. We have to look at everything beyond the product lifecycle, everything that's needed for the product lifecycle as well. It must simultaneously embrace the life cycle of the manufacturing process, the life cycle of the maintenance and support capabilities, the life cycle of the phase out and disposal processes. Remember, we spoke about that, right? After sales service, Apple, which has got this returns policy where you can take in your own products, they refund you for it. Why? So that they can recapture all the precious metals and stuff out of the phone or whatever the case may be. Okay. So this is where I wanted to get at, and this gives us a clear idea of what we say when we consider systems engineering. Let me just take a sip of water. Give me a moment. And guys, also just feel free to interrupt me at any point if you've got a burning question. Remember, this is a symbiotic learning experience. I learn from you, you learn from me, your buddies learn from you, you learn from your buddies, all of that. So let's try and keep that environment going. All right, so what do we think when we say product life cycle? We think of that top block. Yeah? We think of conceptualizing the product, preliminary design, detailed design, production, and then product use, phase out, and disposal. So that is the series, what happens in series chronologically. Yeah? So there's the acquisition phase, and there's the utilization phase. So all of that makes sense. But as systems engineers, it doesn't stop there. We don't look at the product alone. We look at all of the support systems, all of the additional stuff that's required, right? Why? We have to consider the manufacturing plant. So if we build a product that requires a huge manufacturing plant, obviously our total cost is going to increase and we won't be able to be competitive. So we have to not only design a product that meets customer needs, but also consider how are we going to produce it? How are we going to manufacture it in order to keep the cost of that product down, right? And then also when we go into production, we start sales, we have to consider, okay, out of sales service, right? We spoke about cars being serviced. I remember back in the day when McLaren, the car producer, McLaren, started producing commercial cars again. It was the MP4-12C or something, was their first production car again in, I think, 20, 30 years, right, when they started producing production cars as well. I saw an interview with their CEO where he said, yeah, everyone must remember, we're not just producing a car, we're producing a brand, because there's no representatives in all the countries. So if we want to sell the car, how are we going to sell the car if there's no dealerships in South Africa, for instance? How are we going to do after-sales service if there's no service center for McLaren in South Africa? So they're not just producing a car. They're setting up an entire network. And it's a lot more than just the car. Yes, the car was awesome. Yes, the car took the entire industry by storm. But what good is the car if I want to buy one in South Africa, but I can't buy it because there's no suppliers here, or I can't service it because there's no service centers here, right? So they had to set up the entire chain, not just the car. So that was very interesting for me, but here you can see it. So when we start production, we have to make sure that this entire after sales chain is also available. We have to make sure that we've got outlets where we sell this stuff. We have to make sure, and in car manufacturing, automotive manufacturing, it's even more important because there has to be parts supply there. So yes, there's after sales service, yes, there's warranties and all of that. But I have to make sure that all of those parts are also available in all the areas, because just now one guy drives over through a pothole and nothing is covered by warranty and nothing is included in the service plan, but there are still parts that I have to replace, right? So I have to make sure that those parts are also available, that the service centers are there to be able to fix the car, right? And that's before I sell the first car. Before I sell the first car, that has to be available, right? So that you can see chronologically where all of this fits in. While I'm busy with conceptual design, I'm already considering how will I manufacture this product. While I'm doing detailed design, I'm going into a lot of detail of what the manufacturing systems are required as well. And I actually start configuring those manufacturing systems. So when my product comes to production or construction, those systems are already ready to start producing there. And when I start producing, even before the first car is sold, I have to make sure that my infrastructure, my sales infrastructure is in place so that when I do sell my first car, and it happened to someone that I know, I was very scared of that happening to me. I bought a new car and he drove out of the dealership, and it's a new car, it's a fast car, it's a sports car. He drove out of the dealership, and in the T-junction where he gets into the road, someone cut across and hit him on the left-hand side of the door, right? So at that point, obviously, my after-sales service has to be there because those parts have to be replaced, right? So all of that infrastructure has to be developed and in place even before I sell my first car, right? And then obviously product use, phase out, and disposal, all of that has to be there. Before I start disposing my first product, all of the infrastructure to be able to dispose of that product or phase out of that product has to be there, all right? And then obviously next to that, product system support, configuration design. So those are network systems, like I spoke about parts and all of that. And then support and maintenance, sorry, I spoke about there. Those are production operations. So that was talking to the manufacturing plant. The after sales service comes in there. Sorry, I made a little bit mistake. But you can see chronologically when that stuff must be there. So by the time that my first product has to be produced, my entire support system has to be designed and in place. And then I can start support and maintenance when the first car rolls off the lot, right? And then obviously finally product system retirement, phase out and disposal. Phase out and disposal is a consideration that must start right in my conceptual and preliminary design these days. I saw, when was it? It was last night. We opened a can of peas to eat last night. We opened the can and I looked inside the can and I was very surprised to see, but this isn't a can anymore. This is a paper tube with a tin top and bottom, because on the inside it was white as well. I don't think it's paper. I don't think it's paper, but it's definitely some or other disposable composite there. And I found it very interesting because it was in a can of peas, right? So when you start designing, obviously you have to consider phase out and disposal as well, right? And that starts with conceptual design. These paper straws and stuff that people are thinking about. That was one of the preliminary design concepts, was to develop something that's environmentally friendly. So in the very first stage of design, one of the design parameters was phase out and disposal, right? So that has to start right at the beginning, all the way through to where those products actually starts to be phased out. All right, so I hope this is quite an important graph, just to give you an idea of how these parallel lines work together and what systems engineering looks at. You can see that, no, we're not just focusing on the car. we're not just focusing on the car and the life cycle of the car. We're focusing on all of this stuff. I remember when we were building dams at Water Affairs, we had borrow pits to install the pipelines. So you don't just dig a hole and put a steel pipe in the hole and then cover it up, right? So those pipes are going to get hurt. The coatings on those pipes are going to get hurt. So you dig a trench, and in the trench, you line it with certain types of materials to ensure that the pipe coating is intact. Otherwise, that pipe is not going to last as long as it should. Because if the coatings aren't there, it's going to rust and all of that stuff, right? So you have to layer it with gravel and sand and certain types of backfill material, right? So for that, we opened borrow pits, which is basically an open cast mine at the scale of which we built pipelines. Remember what I told you about what the size pipelines are that we built, 70 kilometers long. You can drive a car down it, right? So it's big pipelines. So to be able to fill a 70 kilometer trench with backfill, obviously it's quite a substantial open cast mine to be able to produce that. And before we started those projects, law these days state that if you so those open pit mines, those borrow pits that we opened up, they're so big that we needed a mining license for them, right? So they're so big that we required a mining license. So we had to apply for a mining license. And I don't know if you know, but if you want to get a legal mining license in South Africa, you have to consider closing up and rehabilitation when you apply for the mining license. And it has gone so far these days that you have to put the amount of money to be able to rehabilitate that open cast mine at the end of your life cycle of that mine. You have to put that money in a trust so that it's there and it can't be wasted. That's how far legislation has come these days. So when I start a mine, before I dig my first hole, I have to put the money in a trust so that that money can be used to rehabilitate that mine. So talking about phase out and disposal, phase out, right? So that is a part that we had in our very first conceptual preliminary design. When we started designing, we had to consider, listen, but legislation says we have to put money in a trust to rehabilitate the mine afterwards. And yes, in those projects, it was a big problem because I was working at Water Affairs and we were paying, and that trust lies with the Department of Environmental Affairs, and the legislation is put up by the Department of Mining. So it was a big interdepartmental issue because you can't transfer money from one department to another department. That causes obviously fiscal problems with the budget, right? You can't just transfer money from where the Minister of Finance allocated it. You can't just transfer money from Water Affairs to mining. You can't just transfer money from Environmental Affairs to Water Affairs, right? So that's an issue. So that was a big problem that we had there that we had to sort out. But just to give an idea of how far this has gone in terms of phase out and disposal, these days you have to put the money for phase out and disposal in trust. That money must be there even before you open, before you dig the first hole. Guys, so this is a very important graph, and I want to spend some time on it. So do you have any questions or anything that you want to raise before we carry on? You can raise your hands. I see a hand raised. Let me just see who that is. Sekatane. Yeah.
Good afternoon, sir. How are you?
I'm all right. How are you doing?
I'm good. I just want to ask, like, if so the system life cycle graph, the one that you were just showing us.
Yeah.
If it is applicable, is it applicable? First of all, is it parallel to maybe in a service type of company where they're offering a service? Would these stages be similar, or there's a specific graph for that type of a product, if the product is a service, for example? And could you, like, just if they are the same, could you, like, give maybe like an example similar to how you did with like a car, so on, and if it and how it applies there?
Yeah, a very good question. You caught me a little bit off guard, so you give me a moment just to get my bearings. Okay, let's say a service-based industry, something like a plumber or electrician or something like that, right?
Yes, sir.
Okay. Okay. So if I'm a plumber, I don't have the buckies I need. I don't have the tools I need. I don't have the licensing that I need before I start. Yeah? And I have to consider after sales service, obviously, because when I come in and I fix your pipes at home, what if they aren't fixed? What if something goes wrong? I had a case like that in my house. All right, so I have to consider that. I have to consider the 30 days of payment that law requires. So I have to work for at least a month before I see my money, right? In most cases, it's even longer. If you work for Eskom, if you're a subcontractor for Eskom, that's 60 days. So it's 60 days after you rendered your service that you only get your money. So you have to carry all of your costs for 60 days. But law basically requires for 30 days unless otherwise stated, right? So yes, it is a little bit different. So you here you might not focus on a product, but you will focus on a service. So your conceptual and preliminary design will include a service, right? So this will typically include your support services. So if I'm a plumber, what do I need? Maybe I need a call center, right? I have to have a call center running at that point. And these days, you can rent call centers, right? You can rent space at a call center. You give them a script and they handle all of your calls for you. You get virtual offices these days. If I'm a plumber and what I know is pipes, right? I don't know much about client service. I don't know much about sales. These days, you can get companies that do that for you. I know of a few companies that does virtual companies. So they've got an office somewhere. It's a rented office, and I pay a certain fee there for them. And what they have is they have admin personnel that answer the phones. And when they answer the phone, they can answer it with your company name. There is boardrooms there that you can use if you want to meet someone, but you don't rent that place permanently. That place, a whole lot of other companies also uses that place. So there's a few examples down in Linwood Road. There's one of those virtual companies up there next to that mall. What's that place? I can't remember. Anyway, there's some of that eco village there. That's some of those virtual companies. So, for instance, I'm a plumber. My preliminary design is about the service that I want to render. Am I going to charge for call out? Aren't I going to charge for call out? My brother does a service in terms of not manufacturing. He does custom kitchen designs, right? But he does quotes. And does he charge for those quotes or not? Because at this point he's doing a lot of quotes, but he's not getting any jobs. So he's spending all of his time on it, but he's not showing an income. Why? Because he doesn't charge for his quotes, and those quotes can get quite detailed. He has to practically design the whole kitchen before you can quote, and that takes him a lot of time. So it's his time wasted that he's working for nothing. So you have to design your service, and then you have to design it in detail. So if I do charge for quotes, how am I going to charge for quotes? Do I do a preliminary quote and then a full quote, which I'm charged for? Or how am I going to do it? What support infrastructure am I going to need? Am I going to need a call center? Am I going to appoint someone to handle the calls? Am I going to go to one of those virtual offices? And then system support. If I do this service, and what type of warranty am I going to give on my service? So I'm a plumber. I come in and I fix your geyser, and I go out and I tell you, listen, I'll give you a 12-month warranty on that geyser. If it breaks in the next 12 months, I'll come back and fix it. So you have to look at that, and then obviously how much time are you going to spend on that warranties, right? So if I do a proper job the first time and I fix your geyser, and your geyser is fixed, then I never have to come out again. But if I do a poor job and every second geyser that I repair breaks, I'm going to spend a lot of time on maintenance and support or after sales service, right? So there's my call center, and there's me going back to go and fix my boo-boos. And then also obviously phase out and disposal. When is this service that I'm going to give going to become redundant? An example of that is let's say counter to counter deliveries, right? So Fastway and Courier Guy and all of these guys have come and they've replaced counter-to-counter deliveries. I know Postnet used to do counter-to-counter deliveries. I know PEP also did counter-to-counter deliveries, but these days Courier Guy and Fastway and all of those guys are far cheaper than even PEP, and they deliver to your door. So there was a phase out, I expect. Okay, I don't think PEP and Postnet realized it. I think they're still struggling to try and keep ahead on the counter-to-counter. But obviously there was a phase out of that service as well, right? So for instance, I'm a plumber. I do cast iron socket and spigot pipes, right? So the last time cast iron socket and spigot pipes were used was back in the 70s. Right now, everybody uses PVC pipes. Am I going to phase out that part of my service? Am I going to employ plumbers that don't know how those pipes work anymore, that don't know how to use those pipes? Or am I going to keep those plumbers? So I have to consider phasing out those services as well. Sorry, guys, I'm not talking about example that I know. I'm just trying to apply my mind with you. I don't know if that answered your question.
Yeah, it answered it in a way, in a sense. So what I was trying to get from you is like, because you said that that graph is important, so I'm trying to understand, like, in a sense of it. Let's say in a testing scenario, like we have to take that and apply it to maybe whatever question that you would be trying to ask us. So I was just trying to get a different perspective in case maybe you were to ask us about a service industry instead of because yeah, you understand where I'm coming from. Yes.
Not just in the testing environment. I'm not. The knowledge that you gain here isn't important because you're going to write a test on it. The knowledge that you gain here is important because you will use it in your life going forward, right? So maybe you're going to work for someone that is service-based instead of product-based. Most companies are combined, right? So McDonald's, for instance, is both service and product, right? Maybe you're going to work in the banking sector. You won't believe how many industrial engineers work in the banking sector. Yes, that's product-based and service-based, right? So yes, no, it's a very good question that you asked, and you caught me a little bit off guard. I'll go and think about it and see if I can add some value to that at the end of the week. Let's say on Thursday when we meet again. But I hope that I was able to give you some clarity now at least. Sorry guys, my glasses are very dirty. I'm looking through one eye.
Yes, right. You did. Thanks.
Thanks, Mr. Sekatane. All right, everyone happy?
Yes, sir. We're happy.
Excellent, excellent. I always ask the students, are you happy or are you comfortable? Because there's a difference. I don't want you to be comfortable. I want you to be happy. And what's the difference? The difference is a Mercedes is very comfortable, né? But a Ferrari is very happy. You're very happy when you're in a Ferrari, but you're not comfortable. All right. So I always ask the people, are you happy? I don't ask you if you're comfortable with it, because comfortable is going to require some studying. All right, guys, let's move on. So product and system life cycles. The life cycle for the maintenance and logistic support activities is also needed to service the product during use and to support the manufacturing capability during its duty cycle. Okay, so that we just spoke about, like the parts supply, the logistics, the service centers, all of that stuff, in order to service those warranties. It doesn't help I give a warranty, but if something breaks, there's no service center in your area. All right, so all of that has to be considered as well. Logistic and maintenance requirements planning should be initiated concurrently to integrate system design features that will ease phase out and disposal. So that's what I said about these things happen in parallel, right? So if you look chronologically, this goes with time. If you look chronologically, where do those things meet? Where do I start designing my manufacturing configuration? I start designing it with my preliminary product design already, right? And the same with the after sales support. The same with the product life cycle. Many times these days, product phase out. Many times these days, disposal is considered as part of our preliminary design. So we start designing that here already, right? In that time frame already, right? So that's what they say here. All of this stuff has to be designed concurrently. You can't just look at one and then after a while realize, oh my word, I never thought about how I'm going to produce it, or oh my word, I never thought about how I'm going to service this product. I'm designing for a 15,000 kilometer service interval, but there's no service centers. I have to run around and set up service centers, right? So I had a few projects like that where the project engineer before me, the system head before me, didn't consider things like that. So he was tendering and all of that stuff, but he didn't consider the mining licenses. And the mining licenses isn't something that the contractor does. It's something that the owner does, that us as water affairs do. So he slipped up there. Some of our tenders didn't even include socioeconomic development. And if you work in projects of that scale, especially in government, that's one of your primary concerns. And that's something that your contractor has to look after, right? But it's a large part of your budget. Now we place the tender and all of a sudden a third of your budget hasn't been budgeted for because you didn't consider it at the right time. All right. So that's something that you really have to consider in your preliminary design already. That's why it makes these phases so important. And that's why systems engineering is so important. So to the extent possible, lifecycle thinking should invoke an end-of-life consideration for recyclability, reusability, and disposability. And that's become even more important after these slides have been compiled, right? Because every single product, every single thing these days have an environmental consideration. I don't think there's many things that are being produced these days. Let's keep China out of the picture, but I don't think there's many things produced these days where recyclability, disposability isn't a consideration anymore. I mean, you can't even have a milkshake at Wimpy without recyclability being in your face, right? So it's really important these days, even more important. Guys, I know we're very early. Okay, let me go through the next 2 slides and then we're going to end. Lifecycle focused design is simultaneously responsive to the customer needs and to the lifecycle outcomes, right? So if the customer needs something, you're not necessarily going to respond as much to that, but you have to consider your lifecycle outcomes as well. To give you an example, has anyone ever thought when they go into a restaurant, when we're talking about straws now, has any single customer ever thought, you know, I prefer a paper straw that goes soggy in my mouth halfway through my drink? Has any customer ever thought that? Has any customer ever said, I like the feel of a soggy piece of paper in my mouth while I'm drinking my milkshake? No customer has ever said that, right? What does the customer need? The customer needs a straw, right? So those guys that produce those straws went to balance those two: life cycle outcomes, disposability, and then customer needs as well. So there is always going to be a balance between those two. If I have a cell phone in my hand, what am I worried about? I'm worried about its functionality. Does it do what it wants to do? Do I care if the system circuits are made out of platinum or gold or nickel, or any of that stuff? I don't care. As long as my phone works, that's customer needs. My phone must work. Life cycle outcomes considers, okay, what materials am I going to use in this? It's not going to have an effect on the client unless it makes the phone slower, but it's going to have an effect of my disposal. It's going to have an environmental effect during production, right? So how am I going to do that? My customer wants a phone that looks good. Am I going to use glass or am I going to use plastic? So is that based on customer needs alone, or is it going to be based on my life cycle needs in terms of production? Right. So it's always simultaneously responsive to customer needs and life cycle outcomes. Yes, the starting point is client needs. It is always client needs. The outcome is client needs. Yes, always. Right through your design, you always go back to your customer needs to make sure that you are on track, that you are meeting those requirements. What I'm saying is no, at no point you're going to reduce your focus on that. At no point you're going to reduce your focus on that. But that doesn't mean you're not going to focus on something else as well, additional to that as well. And that's where the balancing act comes in. So I can't just respond to my customer needs without considering my life cycle. All right. Design should not only transform a need into a product or system configuration, but it should ensure the design capability with related physical and functional requirements. So can you hear that? So we're not just going to take what the customer needs and then develop a product that answers those needs. We're also going to ensure that those design capabilities are actually possible in the working environment, right? That it works with the physical and related requirements. So if I design a car and my customer needs is it must be serviced every 15,000 kilometers. Now I design a car that is serviced every 15,000 kilometers. I must also develop the infrastructure that makes that a possibility, right? So the infrastructure that is required to make that a possibility is service centers. All right. It should also consider operational outcomes expressed as producibility, reliability, maintainability, usability, supportability, serviceability, disposability, and others. So that's all of the stuff that we're talking about, right? And then performance, effectiveness, and affordability. If I need a car that drives 120 kilometers an hour, and as soon as it comes out of the shop, it does, and then 2 weeks later, it doesn't anymore, is that going to work? No, it's not going to work. If I don't consider disposability, right? So I design a phone with a nickel cadmium battery, for instance, because it's recyclable. But I don't have recycling infrastructure for that. What is that going to help me? It's not going to help me at all. All right. So all of this stuff has to remain outcomes, operational outcomes. Producibility. Can I produce this product? A good example of that is when we did pipelines. We designed valves, and for the valves, we designed valve chambers, right? Where you go in and you can open the valve and you can close the valve and you can replace the valve and all of that. And one day I went to site to do an inspection, and the contractor went and he cast out of concrete a valve chamber. And I got in there and I told the contractor, listen, try and fasten this bolt. He said, yeah, no, you can fasten it, because he's got about 0.5 meter of clearance. I told him, no, that's not what I said. Climb in, take the tools and go and fasten that bolt. And he climbed in and he couldn't fasten the bolt, because that's not how you fasten 50 millimeter diameter bolts. You fasten them using a hammer. Okay, I'm going to show you a video of that. You fasten those bolts using a hammer. And yes, he did have 500 millimeters of clearance. Yes, it is long enough to be able to swing a spanner, but you don't fasten those bolts by swinging a spanner. You fasten those bolts by putting a spanner in place and then swinging a hammer to hit that spanner. So yes, you could swing a spanner, but it was definitely not producible. So there's all that type of considerations that must be kept in mind. And that's what we spoke about just now. Okay, guys. So those blocks that we just mentioned in that graph previously, and that map of the 4 coordinated life cycles. Now, each one of those life cycles are broken down in each of these different figures in the book. All right. So I think those figures are here, but you can see that they're quite unclear. So I want to go through them. I want to set up a session where we can go through those figures. So that's why I said I want to stop here today, even though we've still got some time left. So perhaps you can grill me on some of the examples that I gave you with a couple of questions. We still have some time. And then I want to talk about assessment and tests. There's some special arrangements that I want to make with you guys. But that's where I'm going to stop today. Guys, any questions? You want to grill me on some examples? You want to give me some examples that want to catch me off guard so that I'm also forced to think? You can raise your hands if you want to chat about something. No questions. I'm always worried if there's no questions, because that says that I'm either very, very good at lecturing, that you don't have any questions, or I'm very, very bad and that you don't care and you don't have any questions. No questions. Okay, guys, I see most of everyone is online. Okay. Yes.
No, sir, I have one question.
Yeah.
Yes. So the last class I didn't attend, so I just want to be just sure Do we have a project thus far on the content which you've been lecturing us on? Because I can see that it's not going to lead to us just having a project. Okay, I'm not articulating it properly, but yeah, that's basically my question.
Okay, Thomas, I've got very good news for you. We haven't written a test yet. That's what I want to talk about now. So you don't have to stress. We are going to write a test soon, though. I want to write a test next week, Tuesday, but let me just talk about some tests. We have to write 2 tests now, right? So Thursday, I'm going to finish off with chapter 2, and then we must write a test on chapter 1 and chapter 2. But we also have to write a test on that natural science stuff that you did last year. So I'm gonna send you that recording of our lecture again, and I'm gonna give you some practice problems, and then we have to write a test on that. But that has to happen soon. So what I want to do is next week Tuesday in class time, we're gonna write a test on the natural sciences component, and then hopefully later next week we'll write an e-test out of class times to cover chapter 1 and 2. So that's my proposal. Mr. Gressa.
Yes, thank you, sir. I'm not sure if sir's aware, but according to the academic core calendar, there's a recess next week from the 21st to 27th.
Are you serious?
Yes. So wants me to forward.
I'm totally out of touch. Guys, okay. Are you willing to write this week? We can even set it up for Saturday or Friday night or whenever. That natural sciences component. Will you be able to?
Is it going to be online, sir?
Say again?
Is it going to be online?
Yes, it's going to be online, yes. So the time slot's not going to be a problem.
Okay, so I'm suggesting that maybe Saturday at night.
Saturday at night. You must first check that with the other students before you make that proposal.
Yes,
no,
sir, I said I was suggesting.
Yeah, I second that, sir. Saturday night. Yeah.
Okay. Okay, no, that's fine. Okay, that's fine. Guys, what I propose is, okay, so that's the proposal. I'm fine with that. I'll set up the test and then it's ready for Saturday. The test is already set up and it's already ready. We must just get a time slot to write that, but I want to give you guys enough time to study. And it isn't difficult stuff. It's stuff you've done for a very long time. So I don't think it's going to require a lot of time to study, especially if you consider that there's an online lecture that you just have to watch, and that's that. All right, so I'm fine for Saturday, but what I want you guys to do is perhaps go on a group and give a proposed date, and then ask the students to raise their hands, and then we get a date. Or should we do that now? Okay, let's do that now. Right, guys, the proposal is for Saturday. How you raise your hand is like that. So could everyone in agreement with that, writing on Saturday, raise your hands here now? Would you raise your hands? Okay, we've got 1, 2, 3, 4, 5, 6. Okay, guys. Look, 6 out of 57 for me is a 7. 7 out of 56 for me is quite bad. So what I'm going to ask is maybe chat on the group, propose a time slot. I would like to have it done before the recess, but when push comes to shove and you don't have enough time to study, I suppose we can make a plan. But I would really like to finish it off and get it done with and get it behind us. So perhaps go on the group and propose a time. So I just wanted to talk to you about that. The first test on chapter 1 and 2, we're going to finish chapter 2 on Thursday. So this is the work that I've just done. We've only got one lecture left. It's going to go quite quickly. So on Thursday, we're going to finish that off. And then first thing after recess, we're going to write an e-test on chapter 1 and 2. And then I'm going to give you your first semester assignment. Okay, but that's going to happen after recess. So there's going to be enough time for that. My worry at this point is that natural sciences component, because we went on with our lives after the natural science, and I got an angry call that says, listen, you gave that lecture, but you never assessed it. So I just want to assess that so that we can all finish that off and go on with our lives. So please go on the group and chat if you want to do it on Saturday, if you want to do it this Friday. Like I said, I would prefer if we do it before the recess, so then maybe I can use the recess to mark as well. It's going to be online, so you write it on your computer. It's not going to be an issue, but the only issue is time. So please go on the group and then discuss which dates would be fine, and then let me know of the dates, and then we can carry on.
Sir, can't you write during recess?
Why do you want to write during recess? You're a student. In recess, you're at the beach and you're picking up girls.
There's no time for doing that now, sir.
No time for doing that.
Yeah, no time.
Okay, but it's all good proposals. Look, I'm still going to work next week, right? I don't have recess next week. So if you want to write it next week, I'm fine with that. But what I propose is, instead of us going back and forth and back and forth and back and forth, perhaps go on the group and make, let's say, put 3 dates down, and then everybody replies with the date that they prefer, and then we can count them up, we can sum them up, and then we can choose a date to write. That suits us all. Okay, so I think that's my homework for Thursday is to go and chat in the group when you want to write. This week, even tomorrow is fine, but I know it's not going to be fine for you. This week is fine, next week is fine. But if we write it as soon as possible, it would be better. All right, guys, thank you very much. Thank you for attending. It's always really, really great for me to give these lectures, because your attendance and your participation is great. So thank you very much for that. Sorry about last week. Last week was very messy. It was a very rough week. But we still have a lot of time and we're still on schedule. Our schedule says that we must finish chapter 2 at the end of this week, and we are still there. We are going to finish chapter 2 at the end of this week. So thank you very much for your participation. I really appreciate that. Okay, guys, thanks. So with that, let's close our lecture. I'll then see you guys on Thursday morning. Thanks and bye.
Anko, asibonge.
Izinja, izinja.
Izinja, asibonge.
Hey, Kwadu.